Welcome to Maths Guru Educational Services. If you are studying with us on Maths Guru channel for the first time, or you have not subscribed to our channel, please kindly subscribe. Please share our video and also comment to help us serve you better. Today we are going to discuss the 13th unit of this course material. It is about standard scores. So in this discourse we are expected to be able to define the standard scores, the Z scores, the T score, and the Stanine or standard 9 score. So this is the focus of this lecture, and we are going to learn how to calculate the Z score and the T score. We have a set of questions here taken from the past examination to guide us in this discourse. The first question is related to this discourse. The C question here related, and we have 5B related to the discourse as well. This is taken from 2019 question. Alright, we discussed the standard scores. Individual score of a student cannot give a better judgment of his or her performance in a particular subject or score. So a better judgment of one's performance is given in relation to others' performances in the same or different subject or course. This is possible by converting the raw scores, that is the score of each of the students, into a standard score. So with standard scores now, we can then compare and add meaningfully the scores of students. So standard scores locate an individual in terms of how much above or below the mean his score falls. So we are talking about how much the person scored above the mean, or how much the person scores below the mean. So there are interval measures which serve a purpose similar to that of the ordinal percentile ranks. We have the Z score here. This is the basic standard score. Take note of this. It is a type of standard score norm in which both the raw scores, the mean, and the standard deviation are considered in the process. The mean, the standard deviation, the raw scores, they are all considered whenever we talk of the Z scores. It is a standard score in which a deviation from the mean is expressed in terms of the deviation of a raw score from the mean divided by the standard deviation. What we're saying is the Z score is defined as the deviation of the mean from the raw score. That is, if X is a raw score and we have X bar as the mean, we divide this deviation of the mean from the raw score by the standard deviation of the scores, the standard deviation. So we can represent it by S, or use the sigma sign. So don't be confused when you see it expressed this way: x minus the mean over standard deviation is still the same thing. We have the sample mean and the population mean. They are all mean. The z-score describes how many standard deviations each test score is from the mean. So a z-score of 0 is average. Be mindful of this. A z-score of 0 is average. Okay, let's take a look at this. 5 students, Ade, Bala, Comfort, Danjuma, and Ejiro, obtained the marks stated here. Let's quickly put them down. We're going to solve this together. Ade, we have Bala, Comfort, Danjuma, and Ejiro. All right. Their marks are 45, 60, 10, 89, and 52 respectively. Now recall the formula for calculating the z-score. We are going to calculate the z-score using that formula now, which is the z-score is equal to the raw score minus the mean of the sample given to us over the standard deviation S. So for each of these, we're going to use this formula and then get their z-scores. All right, for Ade, we have a raw score of 45, so his z-score will be equal to 45 minus the mean is given as 51.2, and then we divide it by the standard deviation, which is 25.47. So the z-score is going to be negative 6.2 over 25.47, and this will give us negative 0.2 approximately. Now for Bala, we're going to have the z-score to be equal to the raw score, which is 60, minus the mean 51.2 over the standard deviation 25.47. So we're going to have 60 minus 51.2 is equal to 8.8, and when we divide it by the standard deviation 25.47, we're going to have approximately 0.3. Now we have for Comfort 10. The raw score is 10, so we have the z-score to be 10 minus the mean, which is 51.2, and then we divide it by the standard deviation, which is 25.47, and we're going to have a negative. It's going to give us negative results 41.2, and when we divide it by the standard deviation 25.47, we're going to have it the z-score as negative 0.6 approximately. Then for the raw score of 89, we're going to have the z-score to be 89 minus the mean, which is 51.2, over the standard deviation, 25.47. And this is going to give us 37.8. Please confirm 37.8, and then we divide it by the standard deviation, 25.47. So the Z score is going to be approximately 1.5. Then for A0, we are going to have the Z score to be equal to the raw score, 52 minus 51.2, over the standard deviation, which is 25.47, and we're going to have the score as of 52 minus 51.2. We're going to have 0.8, and when we divide it by 25.47, we're going to have approximately, the Z score is going to be approximately 0.0. All right. Wow. So this is how to calculate the Z score anytime we are given this kind of question. Now let's talk about the T score. From our calculation of Z score, you have seen that a Z score of 0.3 means that the raw score has a spread or is located 0.3 standard deviations above the mean. In the same way, a Z score of negative 0.2 indicates that the score is located 0.2 standard deviations below the mean. If it is negative, it is below, and if it is positive, it is above. But if it is 0, if the Z score is 0, as in the case of A0 here, it means it is average. Take note of that. We mentioned that when we're discussing the Z score then. So you have also noticed that the Z scores are very low and sometimes have negative scores and decimalized scores. A Z score distribution can therefore be transformed to a new distribution where there are no decimal points and negative values. The decimal point is eliminated by multiplying the Z score by some convenient constant, while the minus sign is eliminated by adding another constant to each Z score. One of the most popular and convenient transformations is to convert the Z score to a distribution which has a mean of 50. And then a standard deviation of 10. So it is called the T score or Z sorry, this is not there. It is called the T score. It is given by the formula T equal to 10 Z plus 50, where the 10 here is a standard deviation and the Z here is the Z score, and 50 represents the mean. So we are saying that the T score is equal to 10 of standard deviation multiplied by the Z score plus the mean of 50. That is the formula for calculating the T score. T score is equal to 10Z plus the mean of 50. This is what we're going to use to calculate the T-scores of these students given to us. All right, so we are going to copy some items from here. That is, we're going to pick their Z scores. Okay. All right, so we can drop that. We have first person Ade. We have Bala. We have Comfort. We have Danjuma and Ejiro. Okay, we are going to calculate the T-score now. The T-score, and we recall that the T-score is calculated using the formula T equal to 10Z plus 50. So we have for Ade now, the T-score is going to be 10 times the Z score is negative 0.2. Then we add 50. 10 times negative 0.2 we give negative 2. Then when we add it to 50, we are going to have 48. That is for Ade. Now let's calculate the T-score of Bala. We still employ the formula. We have 10Z plus 50. Then we have 10 times positive 0.3. Then we add the 50. All right. So we're going to have 10 times 0.3 is 3. Then plus 50, we're going to have 53. So this is the T-score of Bala. For Comfort, we have the T-score given as 10Z plus 50. And we're going to have 10 multiplied by negative 0.6. Then we add 50. 10 times 0.6 is going to give us negative 6. Then we add 50. If we add 50 to negative 6, we're going to have 44. Then for Danjuma now, still use the same formula, 10Z plus 50, and we're going to have 10 multiplied by the Z score is 1.5. Then we add 50. 10 times 1.5 is 15 plus 50. So we're going to have 15 plus 50 to give us 65. Then for A0 we have 0. So the T-score is going to be 10Z plus 50. So we have 10 times 0.0 plus 50. So 10 times 0 is 0. Any number multiplied by 0 is 0. Then we add 50. 0 plus 50 is going to give us 50. So the T-score for A0 is 50. Anytime, any day, this is how to calculate the T-score of a given set of scores given. All right, we move on. Here we have a question picked from the question shown earlier. The Z-score of Mary's score in statistical method is negative 1.5. Calculate the T-score. Already the Z-score is given. So remember, t-score is equal to 10z plus 50. So we're going to have 10 multiplied by negative 1.5. Then we add 50. 10 times negative 1.5 will give negative 15 plus 50. And we are going to have negative 15 plus 50. That will be is the same thing as saying 50 minus 15, which will give us 35. So the t-score is equal to 35. Now we have the last one, the Stanine or standard 9 score. The Stanine scores are used in education to compare students' performance over a normal distribution. So Stanine scores convert raw test scores to a 9-digit whole number to signify test interpretation. Typically, Stanine scores between 4 and 6 are considered average. You can see that here. Between 4 and 6, we have the average. 1 to 3 is below average, and then 7 to 9 is above average. All right. We have considered average. Scores of 3 or less are below average, while scores of 7 or greater are above average. Okay, it is a method of scaling test scores on a 9-point standard scale with a mean of 5 and a standard deviation of 2. The mean 5, standard deviation of 2. Now take a look at this. We have the 9 scales here: 1, 2, 3, 4, 5, 6, 7, 8, 9. So the mean score is 5 and the standard deviation should be 2. Take note of that. Mean equal to 5, then standard deviation should be equal to 2. That is what we are saying. The pro of this standard score is that in standard scores, we are enabled to gain a quick understanding of where a given test score lies relative to all other test scores. For example, we know that a student who receives a test score in Stanine 5 belongs to the middle 20% of all test score. And we know that a student who falls in Stanine 9 received a test score in the top 4% of all scores. So we know that those from, let's say, Stanine 1 to 3, once you see something, a score like that, we know that the person is below average. And if someone has a Stanine score of 4, 5, or 6, you know that the person is an average student. And if someone scores more than that, that is having a Stanine score of 7, 8, or 9, you know that that person can be classified as a student above average. Take note of that. But the con of this score is that each Stanine is not equally sized, and a test score in a given Stanine could be closer to scores in the next Stanine compared to the scores within his own Stanine. For example, student who receives a score in the 40th through 68th percentile are all grouped together in Stanine 5. However, a student whose test score falls in the 58th percentile will be closer to the scores received in Stanine 6 compared to most of the scores received in Stanine 5. But still, the people within that range will still be classified as those in Stanine 5. That is the con of this standard score. All right, please, if you like this video, do not forget to subscribe to our channel, share our video, please like and comment. Very important, comment. We know how to serve you better by doing this. We love you and we are at your service. Thank you. Have a great day and good luck in your examinations.